this video, you will learn how to solve geometrical problems involving position vectors. In order to do so, let us recap. To find vector AB, we can use the triangle law of addition to add vector AO plus vector OB. And we know that vector AO will be the negative of vector OA, and hence, to find vector AB, we can simply use vector OB minus OA, whereby vector OA and vector OB are what we call position vectors. So, position vectors are vectors starting from the origin to the point A or the point B. In the diagram, OAB is a triangle. The position vectors of A and B relative to O are given to be vector A and vector B. M is a point on AB such that AM to MB is 1 to 2. N is a point such that vector ON is equals to half of vector AB. And this means that ON is parallel to AB. We are asked to write each of the following in terms of vector A and B. First, let us find what is vector AM in terms of vector A and B. From the diagram, we know that AM will be equals to 1/3 of vector AB, and vector AB will be equals to vector OB minus vector OA, and we will have 1/3 brackets vector B minus A. Next, we are asked to find vector NM. Vector NM will be equals to vector OM minus ON. Since we do not have vector OM, we will have to find it first, and vector OM can be found using OA plus AM. This is because we have both OA and vector AM, and we will have A plus half multiplied by vector B minus vector A, and this will simplify to 2/3 of vector A plus 1/3 of vector B. We also have to find vector ON, and we know that vector ON will be equals to half of vector AB, and so we will have vector ON equals to half of vector B minus A. Putting in both vector OM and vector ON in terms of vector A and B, we will have 2/3 times vector A plus 1/3 of vector B minus half bracket vector B minus A. And simplified it one last time, we will have 7/6 of vector A minus 1/6 of vector B. Next, we are asked to find the position vector of the point P. That means we are asked to find vector OP such that vector NP is equals to 3 times vector NM. And so we will have OP minus ON equals to 3 times of vector NM. In order to find vector OP, we will need to find 3 of vector NM plus vector ON. we have here vector nm, and that will give us 3 multiplied by 7 over 6 of vector A minus 1 over 6 of vector B. Now, what's about ON? Vector ON was found earlier to be half of vector AB, so it will be half of vector B minus vector A. Simplifying it, we will simply get 3 vector A. Finally, we are asked to find the value of area of triangle OBN, which is this triangle here, over area of triangle OBA. Now these two triangles have a common height h here, and this quadrilateral is a trapezium. So we can simply use the formula for area of triangle half times base. For the base of this triangle OBN will be ON times the height over half times the base of triangle OBA will be AB, and we'll multiply by a common height. Since ON equals to half B minus A from the previous questions, and AB is equals to B minus A, ON over AB will simply be 1 over 2. And this is how we solve geometrical problems involving position vectors.